Okay, we have a windmill, and the acceleration of the blades, because it has a gust of winds, is based on theta, not time. And the blades initially have an angular velocity of 5 radians per second. So the blades are already spinning, it gets a gust of wind, it speeds up at that amount. So determine the speed of the blades at point P, locate the tip of the blades just after the blades turn 2 revolutions. Alright, so here we are. We get a gust of wind, it speeds up from 5 to something. Now we don't have time in here, so the best equation to use when there's no time is alpha d theta equals omega d omega. And that's very similar to the a ds equals v dv equation we used back in chapter 12. So we are going to put in the alpha equation here, so 0.2 theta d theta, we'll integrate that, and then we'll do omega d omega and integrate that. Now alpha d theta we're going to do from 0, and it wants to know after the blade has turned 2 revolutions, and 2 revolutions is of course 4 pi. So we'll integrate this one from 0 to 4 pi. And this one, it starts at the initial velocity of 5, so we'll do that one from 5 to omega, the unknown. So the integral of 0.2 theta is of course theta squared, 0.2 over 2, from 0 to 4 pi. And that equals 1/2 omega squared from 5 to omega. 0.2. So 0.2 over 2 is 0.1, and theta 4 pi squared. 0 doesn't matter because 0 is times whatever is 0. And then we'll do 1/2 omega squared minus 1/2 5 squared. So the only thing left in here is omega, and solving that we get omega is equal to 7.52 radians per second. The question is what is the velocity? What is the speed? So we need to convert from omega to velocity. So v equals omega r, and so that equals 7.52 times r is 2.5. So v equals 18.8 feet per second.